Good morning, friends. In this video, we are going to solve a numerical problem on voltage divider bias with the dual supply. So here we can see there is plus 5 volt and also minus 5 volt. The values of beta, RE and RC are given. We have to design a bias stable circuit such that the quiescent voltage output voltage is 0. So here is the output voltage. You can see V naught. Now the first thing is we have to draw the DC equivalent circuit. To draw the DC equivalent circuit, we have to make this the CCS open. So we will get only this R1 and R2 and the remaining part. Now we already see how to get this VTH and RTH. But here we are having two supply. One is plus 5, another one is minus 5. So now we will see how to get this VTH. So first, what is VTH? The Thevenin's voltage from the base with respect to the ground. So if we redraw the circuit, looking into the base, so I can write this as there is a plus 5 volt and R1 resistor. After this there is a R2 resistor. The end of R2 resistor is previously it was grounded in the last video. Now it is connected to a negative supply. So I can write it as V minus. So these V minus is minus 5 volt and this is grounded. So what is VTH? VTH is, this is the base. The voltage from here to here is VTH. This point is grounded. VTH. So VTH is voltage across this resistor R2 plus this V minus. So how can I write this? VTH equal to voltage across R2 plus V minus. Now I have to find what is VR2. Okay, for that I am redrawing the same circuit as. So there is a, you can see there is a plus 5 volt here. There is a plus 5 volt is connected to R1 and then is connected to R2 and after that it is B minus and this is grounded. Now I have to find VR2 which is the voltage across this resistance R2. I am going to use a superposition theorem which says that we can use at a time we can use only one source, remaining I can make it to 0. In case what is the first circuit is R1 B plus, I am making B minus to be 0. So B minus is 0 R2. Now what is the voltage across this resistor? Let me take BR2 A. So total voltage into R2 divided by R1 plus R2. Now the second thing is I will make this B plus to be 0. So the circuit will looks like R1, R2 and B minus and this is here, this is ground. Now if you see here the direction of current from here to here is opposite. So what is BR2 B minus minus of B minus divided by R2 divided by R1 plus R2. So now the total voltage across this resistor R2 is the summation of VR2 equal to VR2A plus VR2B, that is equal to, if you take this R2 divided by R1 plus R2, this is B plus minus B minus. So what is Thevenin's voltage? VTH. Thevenin's voltage is BR2, which is R2 divided by R1 plus R2 B plus minus B minus plus B minus. I have written from this equation. Thevenin's voltage. Now we have got the equation for Thevenin's voltage. Now we got the Thevenin's voltage, and the next is RTH. RTH is R1 R2 divided by R1 plus R2. So this we got BTH and RTH. Now the main thing we have to start, and now in the question it was mentioned as the output quiescent voltage as 0. You can see here, design a bias stable circuit such that the quiescent output voltage is 0, which means V naught, the quiescent output voltage, this is to be at Q point, this is to be 0. So what happens here? The collector current IC, the direction of the collector current is this. So this is like, we can draw is like this. This point is B naught. This is mentioned as 0 at Q point, and this point is plus 5 volt, and this is RC, and this is IC. Okay, so from this what we can say? ICQ equal to 5 minus this V naught is 0, which is given in the question, divided by RC. So RC is 1 kilo, so ICEQ is 5 milliamps. From that we can calculate what is IBEQ. IBEQ equal to ICEQ by beta. The value is given as 0.0333 milliamps. Beta is 150, you can substitute and we can get this values. So the next thing is, in last video we have seen what is the condition for RTH. RTH equal to 0.1 1 plus beta multiplied by RE. So we know what is beta and RE. Substituting this, we will get RTH as 3.02 kilo ohm. If you didn't understand this equation, please refer to the previous videos. So we got what is RTH. Now we have to write KVL at the input loop at this point. So here it is minus VTH plus this current, if you take IB RTH plus BBE plus IERE, and here it is minus, either you can say it is plus of V minus or minus 5, that is equal to 0. If you see here, we got what is ICEQ and IBEQ. So we know IEQ equal to IBEQ plus ICEQ. So we know what is this IEQ, BBE is 0.7, IBEQ is given here, RTH also we got. From all this equation we can find what is VTH. So VTH equal to minus 3.193 volt. VTH equation we have derived. So in this equation, just I am going to multiply and divide R1 to just make the equations simple for calculation. So this 1 by R1. So multiply and divide by R1, which gives R1 R2 divided by R1 plus R2 is nothing but RTH. RTH divided by R1, this B plus minus B minus plus B minus, that is VTH. VTH we got just minus 3.193 volt, that is equal to RTH. We know that what is the value of RTH is 3.02 kilo ohm divided by R1. B plus is 5 volt, B minus is minus 5. So 5 minus of minus 5 is 10 plus minus 5. So this BTHS is minus 3.193, that is equal to 30.2K divided by R1 minus 5. Solving this equation, you will get R1 equal to 16.712 kilo ohm. So after calculating R1, we know that R1 R2 divided by R1 plus R2, that is equal to 3.02 kilo ohm. Now we know this R1. Substituting this, we can find R2 as 3.685 kilo ohms. So we have got both R1 and R2. So we have solved this problem. The question, it is asked to design a bias stable circuit. That is, we have to find the value of this R1 and R2 that you have completed. Thank you.